a warm welcome from my side to that web seminar, and also thanks to the team of Ingram Micro for giving us the opportunity to present in this web seminar typical scenarios of our customers or our users. To my person, my name is Marcus. I'm head of Competence Center Applications, and I work as a technical consultant at INSYS ICOM. My team and I, we focus on technical consulting and support for customers and partners in pre-sales and projects. Our goal is to work with you or your customers to develop the best possible solution with our products. I am located at INSYS headquarters in Regensburg, Bavaria, Germany. And now I'm happy to guide you through the following lesson and enjoy. First of all, a little explanation, who is INSYS? INSYS Group was founded in 1992 in Regensburg, Bavaria, Germany, and INSYS is a medium-sized company consisting of 3 brands: INSYS ICOM, the INSYS Locks, and the INSYS Test. Of course, for today, INSYS ICOM is the reason why you're listening to this web seminar. And what do we do at INSYS ICOM? To put it simply, we deliver data, or we ensure that access to data is granted, usually in a secure way via the internet or private networks, and mostly, of course, remote. Let us have a short look to our other brands. The INSYS Locks is a creator of intelligent lock systems and software solutions for safes, ATMs, or handling of valuables in general for banks and retailers. And INSYS Test is a specialist for manufacturing, operation and service of test equipment and lifetime simulation systems, mainly for the automotive industry. For those who don't know INSYS ICOM so far, here is a little insight about our products. INSYS ICOM comes from the OT, the operational technology, or to be more precise, from the border between OT and IT. We can and we have to deal with both sides, the machine, or let's call it more general for today, the asset, and the IT, or backend data centers, SCADA system, etc. INSYS ICOM's focus is on access and data provisioning to distributed remote assets in industrial applications. Our product portfolio consists of our routers and gateways optimized for industrial usage with LAN, Wi-Fi, LTE, fiber optic, and DSL connectivity. With our own device operating system called icom OS. Our devices are surrounded by an ecosystem consisting of a VPN service used for remote access and real 24/7 M2M networking. An edge computing platform integrated in our routers, which enables the VPN routers to act as a real industrial IoT gateway by using ready-made software like ICOM Data Suite or project-specific application software securely separated in container virtualization based on Linux. And finally, a central device management system to keep all routers up to date. This is our portfolio in a very nutshell. But now coming to the topic of our web seminar today. What you will get in this web seminar. We will illuminate this topic from different directions. First, starting with the pain points of a typical industrial asset owner. The typical issues our customers have. Different customers, different levels of maturity in their specific needs. You will see how versatile industrial IoT can be. And industrial IoT is much more than just automized production lines, especially in the field of distributed remote assets. There are a lot of opportunities. And to enforce these verticals, a few examples from our customer base. But let's start with the pain points of a typical asset owner or machine owner. The asset owner, the unknown entity, In this context, it means also the asset operator or the machine operator, the machine builder. When we talk about assets in the field, normally we talk about distributed assets all over a country or even international. Some of those assets may work in normal operation. Some of them are perhaps in a maintenance mode, planned or unplanned, and some of them may be just switched to an error state for further analysis. And when we talk about industrial assets, most of you might perhaps think on factory automation lines, true Industry 4.0 projects. But industrial assets, industrial IoT is much more than this. Think on photovoltaic power plants or renewable energy plants or electric vehicle charging stations or building automation, for example, monitoring and control of heating, ventilation, air condition, so-called HVAC systems in retailer shops, for example. Or recycling machines, for example, for construction waste, and much more, like cranes, elevators, gas quality measurement stations, etc. They all have similar pain points. Sometimes they use just different terms for the same meaning. And you can see very clearly, not every asset runs in a perfectly organized factory. On the contrary, often these things run on their own somewhere out in the field. When it's about economy, of course, the efficiency of a plant is the key performance indicator. In some verticals, this is called OEE, which is the overall equipment efficiency. By knowing and analyzing the ratio between downtime, uptime, and output, improvements in efficiency will have direct impact on the business. Firmly linked to efficiency is also quality of the produced good, as it influences the output of a machine, of course. Having distributed assets, the challenge is also to centralize QA work for better benchmarking, analysis, and further improvements. And when you run remote assets, you want to know if it is used and how it is used, for better or worse. As asset or machine manufacturer, use the insights to improve the asset machine itself. The end customer wants to be happy and have access to necessary information about his assets and his machine. So you need to grant access for him and other stakeholders to current status data and to reportings as automated as possible. As a next, whether predictive maintenance or not, at some point a malfunction will occur. Then it is important to know as soon as possible what the problem is and how it came up. Very often, on-site visits are not even necessary or can be prepared in a targeted manner through remote analysis, and downtimes are minimized. Incident management, including escalation options and reporting for verification purposes. As you see, in this industrial IoT applications, the things are a little bigger and consist often of several components or even subsystems on site. Think on a wind turbine or a PV power plant. Normally, for every planned and unplanned maintenance, it is necessary to have really engineering access for remote maintenance. Simple IoT gateways who just deliver data are not enough there. Our asset owner doesn't want to be dependent on where the machine is or where the service department is or where the service person is accessing from. And he also doesn't want to be dependent on a certain infrastructure on site to be able to communicate. For example, which network has to be used. As you can see, the tasks of our customer do not stop at visualization or monitoring for the detection of a malfunction right in time. In order not to leave his remote assets alone out in the field, a remote access solution is always necessary for a round solution. In many situations, you need a tool to name things on an abstract level. Our industrial IoT maturity journey is a tool that works like a map that can be discussed with your customer, perhaps the machine owner, the machine builder, to learn about his path and his status towards an industrial IoT project or digital transformation in general. In our field, every project normally starts with the topic of connectivity. May it be the classical internet connection, for example, for remote access, or to connect locally the devices, the peripherals, the PLC, the HMI, so-called OT components. Very often, connectivity is one of the most crucial topics in a project because it relates to physics, to space, to form factors, connectors, voltage, sensors, temperatures, and of course, internet access technologies. As you can imagine, in retrofit projects or machines which need to be connected in different locations internationally, you need a lot of flexibility. This is why INSYS icom offers a range of different type of devices to fit to that requirement, equipped with icom OS, our own router operating system. And to offer end-to-end connectivity, our icom connectivity suite provides VPN-secured remote access and M2M networking. The next point, operations, is somewhat distracting at this point in the journey, because before one dedicates oneself to set up real IoT solutions and work with the data of the machines and the result and insights and possibly new business models, one must deal with this topic before when selecting an IoT solution, in order to ensure that the solution can also be operated on a larger scale and is not stuck after the proof of concept phase. This is especially true for remote assets. If there is clarity about this topic and the solution is capable of being scalable and remote and automized operatable, then put this topic aside again and start with your proof of concept. But don't forget, the topic of operations always has a direct influence on processes. Also on the part of the solution providers. This part should not be underestimated in projects. Also in terms of integration roadmap and time schedule. Our router operating system, icom OS, provides a lot of possibilities and interfaces to integrate our devices into existing management solutions. And with icom router management, we provide our own centralized, ready-to-use solution for professional device management. Let's move to the first and most simple layer of data-driven use cases in the industrial IoT maturity journey, condition monitoring. Starting from our remote assets, often larger machines or plants consisting of multiple components. In order to monitor the status of such installations, a barrier-free and secure access to the relevant data is eminent. Our devices provide edge computing capabilities in combination with our icom data suite, a ready-to-use software to be installed on the routers. The devices are transformed into a real industrial IoT gateway, capturing and processing data from the machines. Since they are very cohesive, let's look at the next two sections of our journey at once, big data and machine learning. Big data is all about the collection and storage of data, whereas the second section is all about the usage of big data or also streaming data with algorithms and perhaps computer-based intelligence. Also here, our icom data suite or individual application software installed on our devices with edge computing help collecting and pre-process the data. Finally processed, visualized or archived in cloud or SCADA systems. As you remember from the beginning, INSYS icom's focus is on access and data provisioning for distributed remote assets in industrial applications. For all centralized data applications, may it be on modern state-of-the-art cloud-based or classical SCADA systems, we do have partners or have proven compatibility with major players here, as you see in the names listed as example. Now let's have a look in what business sectors and markets our customers and our applications are running. The range of applications in the field of industrial IoT is wide and by no means limited to applications just in the production line or in factory automation environment. Especially in the field of distributed remote assets, there are a lot of opportunities. And the same applies to the markets and verticals in which these solutions are needed. Our main focus markets are mechanical engineering, energy sector, then environmental technology and infrastructure, and building technology. Let's have a closer look to see the definitions and the corresponding sub-verticals. In mechanical engineering, our main customers are machine builders or system integrators, whose products run everywhere things are produced or processed. In the field of energy, our products are used in all the future fields and are part of many modernization and digitalization projects. Several of that verticals are declared as critical infrastructure in the meantime, with a very high demand for formal and functional IT security. The water sector comes very close to the requirements in the energy sector in terms of security of supply. Other sectors in this big market are more oriented in very efficient ways to delivery a special service, whereas the traffic sector mainly is about renewing existing infrastructure. In our definition and in our markets of building technology, this is not about the automation of a building itself, because therefore more specialized products and technologies from other vendors exist, but more to provide remote access or additional edge capabilities in monitoring remote assets. Here, buildings or part of buildings and collecting data, for example, for benchmarking, energy management, or to provide service-oriented products. Now let's have a look on a selection of typical applications from our customers. Let's start really with a machine builder's project, a so-called smart product. Machine builders and their products are characterized by technical excellence in the disciplines of mechanics, electronics, control and drive technology. However, machines are still sold at a one-time price with a maximum of 12 months of service and then service on demand. Once installed at the customer site, the only time a machine builder learns about his own products is when maintenance is performed, may it be planned or unplanned. The product development of the machine builder wants to move away from every machine is individual to more standardization. But this often means that the knowledge of which function is really used by customers disappears more and more. Many machine builders are already taking the path from the machine towards a smart product. This means not really changing the function, but being able to sell the machine as a service. The business model here can vary depending on the industry and type, of course. But they all have one thing in common. In order to be able to map an as-a-service business model, there needs to be a constant flow of information from the machine to the manufacturer. Necessary maintenance work must be covered by the as-a-service business. And maximum availability is important since only running machines generate profit. And data collection on a large scale becomes necessary in order to analyze usage behavior or problem cases on a large database. Remote access, which is already partly available in existing solutions, must also be able to be integrated in such modern new solutions. Because if there is an unexpected problem reported, remote access allows transparent engineering access to the different components inside the machine. In many cases, the machine builder wants to enable also the installed base of machines, so the added value also for existing end customers, for example, for proactive service. And this has to be available without renewing everything in the machine. The solution has to provide relevant KPIs like OEE, which allows the business model to be built on. You need quantity, availability, and usage, for example. The product development can use usage data to improve the product and also as an additional value for the customer. He can have access to parts of this information by just providing standardized interfaces. May it be for visualization, dashboards, or data export, or even programmable interfaces like a REST API to connect to customers' own systems, ERP systems or MES systems, for example. Typical customers use our devices as Industrial IoT gateway connected to an IoT cloud system to collect, store, and process relevant data. In addition, our routers, our devices are really used as VPN routers together with a remote access service like our icom connectivity suite and are therefore integral parts of this whole solution. The so-called energy transition towards more renewable energies is one of the worldwide megatrends, which cannot be denied any longer. Here in Germany, due to its absence of its own fossil fuels, the turnaround has almost been achieved. In the first half of 2022, the share of renewables in electricity generation was already about 47%. In the European Union, it was in 2020, it was 38%, and I think this year it should also be well over 40%. But even in countries with traditional high reserves of fossil fuels of their own, the path is moving towards a significant share of renewables. The United Arab Emirates, for example, has set a target of 31% by 25, compared to about 13% today and 50% in the long term. Especially Dubai will move even up to 75%. Saudi Arabia wants to reach 50% by 2030. And there are similar figures and timeframes for Egypt and Morocco, to name just a few examples. But what does this mean for the energy grid, which in future will be fed by many decentralized power plants, whose generated energy is often also volatile or depending on the time of day, like solar power or wind power? Well, generation plants and electricity grids, but also storage facilities must communicate with each other and, depending on the market, also with other stakeholders, for example, in order to sell the electricity produced. Renewable energy power plants normally consist of different subsystems from different manufacturers. Most of them need secure, reliable communication for different means. May it be the central power management for the grid stability or the communication to a direct marketer to sell the energy produced on an energy stock market. Also, classically generic tasks like condition monitoring or remote maintenance are important. Those tasks are normally done from and for different stakeholders, so that is not unusual that renewable energy plants need several securely separated communication channels. The more interaction between different power grid participants happens, the higher are the requirements for stability, or simple spoken, always online. In some markets, a plant that is not accessible is counted as not working, so that no revenue can be generated for it. And in addition, many of the plants are considered as critical infrastructure, so a high-level, auditable IT security is an eminent part of the system concept. Typical customers use our devices to connect the components and subsystems of the plants and the multiple stakeholders in a very flexible way with different secure channels like VPNs. In addition, using our icom connectivity suite for remote access, there is an end-to-end solution for managed connectivity, for example, for plant service providers. Another very interesting example, the mobile traffic light control. The challenges facing mobile traffic lights are considerable. For best traffic flow, the red and green phases should not be too short or too long. Traffic lights at roadworks are also subject to demands in terms of their energy supply, for example, battery condition and charging by solar cells, as well as occasional vandalism. This means high maintenance costs due to the risk of malfunctions. The management of major traffic light scenarios requires a high degree of know-how, in that an installation has to respond in many variables. Large construction machineries, slow vehicles such as buses and delivery traffic, and changes in the behavior of road users in response to the roadwork situations. A battery's discharge curve can be easily predicted via its voltage level, so a replacement of a battery can be scheduled in good time before a traffic light failure occurs. Diagnostic data provides information about possible vandalism and enables suitable measures to be taken by service technicians. Networking the traffic light control system makes available additional data, which, coupled with calendar information such as weekends and public holidays, can be used to create parameters and plan the optimum switching cycles. Information that becomes available at short notice, such as weather data or schedules for traffic crossing the construction site, can also be incorporated. Clearly laid out dashboards allow parameter changes to be made and monitored remotely. In traffic light systems, the ultimate goal is high availability and high through flows. Systems have to run without interruptions, and traffic should flow as smoothly as possible. Our typical customers in that segment use our IoT gateways connected to IoT cloud systems for the intelligent remote control of the traffic light networks in line with requirements on the basis of the relevant available data. Dashboards displaying all the relevant status values and therefore enable efficient remote diagnostics and monitoring. Our last example for today, it's about industrial gases and on-site supply for that topic. Technical gases, also called industrial gases or process gases, are required in many production areas. This can be, for example, oxygen, hydrogen, argon, or nitrogen, which are used, for example, in metal processing, in electronics production, or also in battery production. In the case of large customers, these gases are not only stored on-site, but are often produced directly on-site, such as by air separators. Process gases are an essential part of the production process, and a malfunction can lead to a production stop in a short time. These complex process plants require service that the customer is not able to provide by himself. The service for these plants is usually organized regional. Here, of course, the service providers need a constant permanent view of their plants, where they are responsible for the service. An integrated fault management system ensures an efficient process for service calls. And in order to gain the greatest possible knowledge about the problem before the service calls, or to be able to handle a service call completely remotely, a remote access solution is required that allows transparent access to all relevant components of the plants, e.g. the main PLC, the HMI, the process CPU. Provide highest availability is the number one goal for the happy customer. But for the service supplier himself, in addition, the goal is to have more efficient and better organized regional service by having a service with more foresight, having the right people at the right place to the right time, or even avoid on-site visits. An INSYS icom IoT gateway and router connected to an IoT cloud and a remote access service like icom Connectivity Suite are integral parts of that solutions. Yeah, that was it from my side for today. This is the end of my presentation. If you have any questions, please write it in the chat. If you haven't done it already, we will answer it afterwards, or contact your contact person at Ingram Micro. Hopefully, we will see or listen in this round again. Please save these dates and register for these web seminars. Thank you and bye-bye.